Chapter review, question number 4. The table shows average monthly temperature T degrees Celsius and the number of pairs of gloves G a shop sells each month. So T degrees Celsius is our independent variable and the number of gloves sold is our dependent variable. Let's quickly draw a sketch of the graph. We have the temperature on the x-axis and number of gloves G on the y-axis. The following statistics were calculated for the data on temperature. The mean is 15.2 and the standard deviation is 11.4. An outlier is an observation which lies plus or minus 2 standard deviations from the mean. Show that T is equal to 50 is an outlier. Now we need to prove that T is equal to 50 is an outlier, and we are given how to calculate an outlier. We take our mean and we add 2 standard deviation, or we subtract 2 standard deviation in order to find the value above which we get an outlier and below which we get an outlier. So let us look at the value on the upper side. So we take the mean. The mean is 15.2. So 15.2, and we add 2 standard deviations to it. So when we add 2 standard deviation, we have 2 into 11.4, and that gives us 38. So any value above 38 is an outlier. We see that a temperature of 50 degrees Celsius clearly is above 38, so it is an outlier. So we write temperature of 50 degrees Celsius is greater than 38, therefore is an outlier. That answers for part A. In part B, we need to give a reason whether or not this outlier should be omitted from the data. So we need to find a reason, or we need to give an explanation as to why the outlier or why a temperature of 50 degree should be omitted from the data. So we are discussing here the temperature and the number of gloves purchased against it. So if the temperature is 50 degrees Celsius, it's a very high temperature, and no one would actually go ahead and buy gloves for wearing because it's very hot. So clearly this data point is an anomaly, or it's a mistake or an error. So the outlier 50 degree must be omitted. So the outlier of 50 degrees Celsius must be omitted, as it is very unlikely that with a temperature of 50 degrees Celsius, anyone would buy a glove, or it would require gloves. So clearly this is an anomaly or an incorrect data entry. That answers for part B. Moving on to part C, the equation of the regression line of T on G for the remaining data is T is equal to 18.4 minus 0.18 G. This is the equation of the regression line, and we have already discussed that equation of the regression line is also similar to equation of a straight line, the general form of which is y is equal to mx plus c. So where m is our gradient and c is our y-intercept. So c is y-intercept. But when it comes to statistics, we write the equation of regression line as y is equal to a plus bx. So here it's the same, but the only difference is the y-intercept is denoted by the letter C. Here the y-intercept is denoted by the letter A. And here the gradient is denoted by the letter M, whereas here the gradient is denoted by the letter B. And that's the only difference between the equation of regression line and the general form of equation of a straight line. So we are already familiar with this. We also know that, for example, if there is a boy standing here with facing his back, if he raises his right hand up, the direction of his right hand is towards a positive gradient, and the direction of his left hand is towards a negative gradient. If we observe the equation of this line, we have a negative gradient. The value of b here, which is our gradient, is negative 0.18. So when we have a negative gradient, we have the line in this direction, which is towards the left hand of the boy. So let's draw a sketch of the line here. It's 18.4 y-intercept. So this is my y-intercept, which is 18.4, and it's towards the left hand of the boy. It's a negative gradient. With this type of a graph, as we move ahead on the x-axis, or as the value on the x-axis increases, then the value on the y-axis is decreasing. So if we move ahead with, for example, if this is the point, the value on the y-axis is decreasing. So when one value increases, the other value decreases. So when we have the slope or the gradient as negative 0.18, that is equal to the gradient, which is equal to rise over the run. So we can say that the run is 1, as it is a fraction, and fraction with negative 0.18 has a denominator 1. What is the rise here? The rise is the number of gloves, and the run is the temperature here. So let's write that. Number of gloves and temperature. So we can interpret this as the number of gloves increases by 1, the temperature decreases by 0.18, because when we have as the temperature increases by 1, because the run is the temperature, as the temperature increases by 1, the number of gloves reduces by approximately 0.18, and that is the interpretation. So as the temperature increases by approximately 1, the number of gloves produced decreases by approximately 0.18, and that is the interpretation of the gradient, which is negative 0.18, and that answers part C.